Hello, I'm going to go through the key idea this week of acids and bases. There's obviously the keynotes video that will give you much more information than on this one. The key idea of an acid is that it's a substance that supplies lots of these very dangerous so if I've got something like hydrochloric acid, when it hits water, it's going to divide up into H pluses and Cl minuses. And it's these H pluses that are very dangerous and reactive. And acids tend to taste sort of sour lemon taste. They react with metals, with some metals, and as you saw last week when you tried the different metals, magnesium was a fairly reactive metal with the acids. And they're used in batteries, they're used for the mining industry, manufacturing, pretty much everywhere. And they will corrode skin, so they are corrosive. Particularly when strong and concentrated. A strong acid is an acid which splits up fully into H plus ions, and a concentrated acid is an acid that's got lots of these acid molecules floating around. So when it's strong and concentrated, it's dangerous. The next thing we're going to have a look at this week are the bases. Bases supply lots of hydroxide, which we call OH minus ions. Classic bases are something like sodium hydroxide. That's a white powder. When it hits water, it turns into Na plus ions and OH minus ions. These are very dangerous and reactive. Bases will tend to feel soapy, taste bitter, used in drain cleaning or oven cleaning. But also the mining and manufacturing industry. And if we place them, just before we place them on a scale, I just think it's important for us to note that they are corrosive. Corrosive means they eat away skin. Eat/attack skin. Eat's probably a bad word. Attack skin. In fact, they're probably worse if they get under the skin. You don't feel them attack as much as acids, but they can do as much damage. Okay, I just want to talk about the third idea this week, which is a pH scale. And the idea of the pH scale, it goes from 0 to 14. Water's sitting in the middle on 7. This is the acidic region of the pH scale. It's the low numbers, and the high numbers are the basic region. As you go up the scale from 7, so as you depart 7, either way gets more and more dangerous, and you're going to have the strong concentrated acids down this end. They'll have a pH of about 0. And the strong concentrated bases will be at the other end. And in the middle we have water. The further away we go from water, more and more dangerous it's getting, the more and more corrosive it's going to get. The further we go to the bases, the more and more dangerous, the more and more corrosive it's going to get. So both 0, you wouldn't put your hand in that, if there's a pH of 0, and you definitely wouldn't put your hand either if it had a pH of 14. You're after something close to a pH of 7 to be safe to handle and not to be too corrosive or too reactive. So that's the basic idea of the pH scale. This week you're going to use universal indicator to measure the pH, and universal indicator changes colour in different pHs. So it can measure the pH by looking at the colour change. Right, so if you look at the colour of the universal indicator, you can actually see that it changes colour, and by looking at the colour you know the pH of the thing that you were trying to test. Okay, hope that makes sense for you this week. Don't forget to watch the first task video, which will give you an idea of how to fill out your task for the week, and the keynotes video contains a lot more information than on this one. Thank you, have fun.